Welcome back. In this video, we're going to explore the concept of distance traveled, displacement, and position. If we're looking for the displacement of a particle that's moving in rectilinear motion, we're going to take the integral from a to b of the velocity. If we're looking for the position, we have to consider the starting point. So you have to start the starting point plus the displacement. And then finally, the distance traveled. This is a key concept. It's got to be the absolute value of the velocity, because that particle could be moving to the left or it could be moving to the right. If you're integrating by hand, they generally don't let this be moving left and right. But if you're putting in a calculator, they do. My first example, I'm asking for the position when t equals 3. I give you the initial point is at -2. So when I look at x of 3, it's going to be the initial point x of 1. Plus that displacement, which would be the integral from 1 to 3 of the velocity. This point right here has to always match that bottom limit. When I worked that out, we started at -2, and then I found that when I did my integral, I added 6 to it, and that equals 4. And the second part, the distance traveled, is going to be given by the integral from 1 to 3 of the absolute value of the velocity. On that interval, the velocity was never negative, so that's just 6. That was that integral that I found first. In my second example, I'm doing exactly the same thing, but this time I'm going to be using a calculator. I did this to show you that sometimes it's moving left and moving right. So we put this in our calculator, and when I did, I graphed it for those 5 seconds, so I let it be between 0 and 5. So I graphed it for those 5 seconds. You can see it moves a little bit left, moves right, and moves back left. And so then I ask you, what is the position of the particle at t equals 4? Well, at t equals 4, x of 4 would be x of 2, which we know to be 3, plus the displacement between 2 and 4 of the velocity of v of t. When you put that in your calculator, since you have it in y1, I would go ahead and bring it back. So quit out of this, and what I would do is I would put in, so for x of 2 right here, I'm going to put in 3. So it's 3 plus the integral, which is math 9, between 2 and 4. And then right here, I'm going to just put in, use the y bars function. So function 1, bring back y1, dx. And so that's going to be 5.226. And then for distance, it's going to be the integral between 0 and 5 of the absolute value of the velocity. And again, you can just put that in your calculator. So it's going to be, again, it's math 9. This time my limits are going to be 0 up to 5. And this time I got to take absolute value of y1. So that absolute value you can find under math, arrow over. Absolute value is that first one. And then inside of there, do the bars, bring back y1 so you don't have to, and then tell it dx. Using that bars function is really helpful. This takes a second to calculate, takes a little bit to get going. I think, waiting, come on, is 4.677. A little bit different wording on the next one. I have a race car that's moving along, and it's given to you as this is my acceleration. I tell you the initial velocity is 80 meters per second, and then they pump the brakes and it's going to stop. And so what I need to do is I need to write a velocity equation, and then I need to integrate that velocity equation to find the distance traveled. So to get a velocity equation, v of t, it's going to be the integral of -6t squared minus t dt. When I integrate that, I get -2t cubed minus 1/2 t squared plus an arbitrary constant. Now that constant, because if I use this initial point at t equals 0, it's 80 meters per second, that constant's got to be 80. So that's my velocity equation. So now what I want to know is okay, how far does it travel between 0 when the brakes are put on and the time it stops? To get the time it stops, I had to graph this. And I did that, and when I graphed it, I got this to be 3.339 seconds. and then the distance traveled velocity would be absolute value of v of t. Again, you don't have to worry about this one going backwards, but nonetheless, you should use absolute value. And I found that to be 198.766, and that would be in meters. And then finally, sometimes we have one that's represented more as a graph. And so what you have is you have a velocity in meters per second. This we're moving left, we're now moving right, and then we're moving left. Remember, this is a derivative graph. So this is the graph of the first derivative because that's what velocity is. And the first question I asked you about acceleration, I want to know whether acceleration is positive. That's where the slope would be positive over here. So that's between 0 and 2. And then again between 6 and 7. And then the next one, I want to know what the acceleration is at 4. So a of 4 would simply be the slope of this line, which I found to be -1. You can choose a couple of points on that line. The next one, I want to know the displacement of the particle. The displacement, I'm going to set up an integral for right here between 0 and 7. So let me do that down here. For part C, it would be the 0 to 7 of the velocity. And when I evaluated that integral by just using area, I found that to be 3. In part D, this one I'm asking you to find where the particle is at 7. So what I'm going to do is I'm going to take this initial starting point at y equals 3. So it's going to be 3 plus that integral up there. So 0 to 7 of v of t dt. That starting at 3, that integral is 3, so this is 6. And my next one, I ask you to find the average velocity. The average velocity would be 1 over 7 minus 0 times the integral from 0 to 7 of the velocity of v of t dt. So that would be 3/7. And then finally, in the last one, I asked you to find the distance traveled, which would be the integral from 0 to 7 of the absolute value of the velocity, which is what it's going to do is it's going to flip this part and this part above the axes. And when I did that, I got that to be 7. Okay, so you got to connect the velocity with derivatives, graphs, all that kind of stuff, all that integration that we've done, some calculator, some non-calculator. I'll see you soon in class.